because inverse operations undo each other, if we had something squared, we'd take the square root of it. So the square root of x squared is x. And this is the simple thought that should be in your brain. Square roots undo squares. What would it take to undo a cube? Cube root. What if you had something to the fourth power? How would you undo it? Fourth root, exactly, right? Because radicals and exponents undo each other. Square roots undo squares. So B, to isolate the variable of a square root of x, if you wanted to get to x, in this case, you'd have to square it, right? You'd have to square it. So the square root of x squared is x, and we've been doing that all along. And again, the start of everything is understand that squares undo square roots. Squares undo square roots undo squares. They undo each other. And the answer is always the radicand. Well, I should say, yeah. In any case, you end up with a radical, and the answer is the radicand. All right, so square roots undo squares, and squares undo square roots. So we got this problem here. What is the velocity of a bowling ball dropped off of a 170-foot cliff? And you're given the formula. 1/2 mv squared equals mgh, where g is 32 feet per second squared. What is g? Say it if you know it. What is g? But what is it? What does it represent? All right, you're scaring me. All right. Gravity. Dropping ball from cliff. What is gravity in the metric system? What's its value? Do you not know? Okay, maybe, I guess maybe you're too young, maybe. 9.8 meters per second squared? All right, whatever. You did know 32 feet per second squared. Okay, all right, you do now. All right, that's standard gravity at sea level. All right, it's basically the idea, just change a little bit as you get away from the center of the earth. What do you think M would be? What do you think M is? Mass. All right, those are lousy arrows. So M is the mass. What happens if you have the same quantity on both sides? On both sides of an equal sign, what can you do? You can cross them off. They really negate each other. And now we're left with 1/2 v squared equals gh. What do you think the h is? That is the height. By the way, this is now the potential energy formula. That's where it comes from, potential energy and such. And then gravity, and it's a combining of those two formulas. But now we end up with 1/2 v squared equals gh. All right, let's plug in the values that we know. So guess what? A half is a half. We are looking for the velocity, aren't we? So that's the variable. And it happens to be squared. Gravity, I'll put in green, is 32. And a wise student always includes their units so that when they're done, they know what units they have. And also, it'll help them know if they make a mistake. And our height is 170 feet. What if the cliff was in miles? We'd have to change miles to feet because gravity's in feet, right? Or feet to miles, either way. All right, so that's the formula right now. What would you do next mathematically to solve this? So somebody raise their hand and tell me what is the next step in solving this. John? Well, yeah, tell me what to do that. Tell me, that's correct. We got to isolate the variable. How are we going to do that? Ethan? Okay, so what do I multiply both sides by? 2, right? Do you agree? Right, we got to move the 1/2. We'll multiply the left by 2. Here, what color's good? We'll use red. Multiply the left by 2 and multiply the right by 2. Right, and that's where we're at. V squared equals 2 times 32 feet per second squared times 170 feet. So let's rewrite. Here's where we're at right now. V squared equals 2 times 32 feet per second squared times 170 feet. That's where I'm at right now. What's the next step? Somebody raise your hand and tell me what to do next. What is next? Hold on a second. I should have every hand up right now. All right. In case you're missing the connection, let me tell you why. Let me go back to what I started the whole lesson with. Square roots undo squares, and squares undo square roots. That's how we started the whole lesson. Square roots undo squares, and squares undo square roots. We are trying to isolate the variable. Agreed? So what is my next step? Should see every hand up, at least almost every hand. So what is next? Sam, what do I do next? Take the square root of what? So just do that. Good. Andrew? Got to do both sides, right? What else do we normally do when we take a square root? What else do we normally need? Normally when you take the square root, you need plus minus. Remember that? Yes, but we don't when we do distance, right? Can distance be negative? No. So you don't need the plus minus. We went over that with the Pythagorean theorem. Brother, I'll tell you how soon you forget. All right, so the left is V. So go ahead and do the square root of 2 times 32 times 170. And we'll get a decimal round off. We'll round it off to the nearest tenth. So calculator, square root of 2 times 32 times 170. And we'll figure out how fast the average really speed of this bowling ball going off this cliff. Somebody raise your hand if you got it. Raquel? 104.3. What are the units? What are the units? What are the units? I keep hearing feet per second and feet per second squared. I didn't hear any feet squared per second squared, though. I don't know why. Because if you're going to say feet per second squared, why aren't you going to say feet squared per second squared? But what are actually the units? What is the square root of feet times feet? Feet. What is the square root of seconds squared? Seconds. 104.3 feet per second. Say, how in the world did you figure that out, Mr. Scarfi? Because the square root of anything is if you have two of them, it's the thing, right? Feet times feet, square root is feet. Seconds times seconds, square root is seconds. All right, so a little bit of science here before we go on. What if instead we dropped a golf ball off of there? What would be the velocity? 104.3 feet per second, negating any wind resistance or air resistance. What if we dropped a feather off of the cliff and there was no wind, no air? There is air, though, so feathers don't work great unless... Have you ever seen a demonstration in a vacuum chamber of dropping a coin and a feather at the same time? If you Google it, it'll come up on YouTube. Dropping a feather and a coin. Mother school, we actually had one. Somebody made it for science fair. And so you put a feather in there and a coin, and you drop them at the same time. It's in a vacuum. They hit at the same time. Because mass has no effect on gravity. That's why I tried to show you the mass dividing out of the equation. Mass doesn't have an effect on gravity. Now, there is air resistance. Anybody see skydivers? What does a skydiver do when they want to slow down? Spread eagle. Because what do you have to do now? Push more air out of the way. That slows you down. How do you go faster? You tuck in, right, and you try to get like that, and you go faster. Why? You have less air to move, right? If I'm like this, aren't I pushing away only the little air in front of me? But if I'm like this, what air am I pushing away? All that air. It's a big difference. All right, but again, negating the air resistance. The mass has nothing to do with it. Shape would only because of air resistance. 104.3. All right, we're going to pick up here tomorrow.